the square root of 2401, right? Every mathematician writes their answer on a piece of paper and signs their answer with their digital signature, let's say. Okay. The presenter collects, the signed responses of every mathematician, right? And then the attendants basically distribute the copies of the signed answer to every member of the audience, right? Now, every member of the audience needs to check that every mathematician agrees or not, right? So there are, let's say, 10 mathematicians in this room, whether all the 10 answers are same or they may be different, right? So the best part or the easiest part of all of this is everyone is, all the answers are same and everyone agrees to it. And then there is a consensus. That's the best, easiest, ideal thing, right? But that's not how it always happens, right? So the problem can be, or what can be the other probabilities, right, to this? If there are 10 mathematicians, right, how many mathematicians should the presenter ask for a right answer? Should all 10, only 6, maybe 7, maybe 8? How many, right? Otherwise, out of 10, how many mathematicians answer need to be in sync for any answer to be accepted as correct? Let's say there are 10 mathematicians. Now, how many, if they answer, let's say 49, how many, if 7 answer 49, is that correct? Should I take it as a correct answer? If 6 answer 49, should that be the correct answer? Should I take it that? That's another approach, right? Okay. And what happens, right, if the presenter of all the proposed answers selects a bad answer, right? So these are all probabilities possible, right? So point is, everybody needs to agree on the rule or the logic or the way we can narrow down on the good or the right answer. So getting to that agreement of what constitutes a good example, a good answer, is nothing but the consensus. And to arrive at a consensus, we need a policy, right? And that policy, we should have what? The audience agrees to the policy. Whatever people agree as a policy should be agreeable to all the people, all the audiences there, right? And there can be multiple policy approaches. All mathematicians must agree to some answer, or majority, let's say 70%, 80%, 90%, whatever, right? This is entirely up to the people who are deciding this to agree on a policy which will arrive at the consensus for them, right? So this is typically what a consensus will talk about. Somebody in the chat was talking about how it was everybody needed in order to come at a consensus and all that, right? How do we arrive at that mechanism there, right? So this is I'm not sure if you will be able to recognize this, but this is a Declaration of Independence which is signed by multiple people. Now, if you see there, this is for US, and there is one for India as well. When we accepted the Constitution, it was signed by multiple people, right? If you see there, the different counties have different representatives who have signed this, right? Delaware, Maryland, Virginia, all of them, that there, New York, New Jersey, right? So that's basically a way of endorsing. They have accepted to a certain constitution or a policy based upon which going forward all the endorsements will happen, right? So typically that, right? So a consensus is nothing but a process of keeping the ledger transactions synchronized so that the ledgers update only when transactions are approved by appropriate participants. Okay, and when ledgers update, they update with same transactions in the same order. So this typically is called a consensus. But before consensus, let's go back and try to understand the endorsement. Okay, I'm sure most of you would have signed a check at some point or some other, right? Normally when we sign a check, right, it is required that we put our correct signature on the check, right? And the amount of money that we are looking to pay to the payee should be available in the bank account, right? So there is some contract, right? That when I'm presenting a check for, let's say, 10,000 rupees, my account should have 10,000 rupees, right? The check should be properly signed with the legal signature which are recorded in the banking system. The check should be legible, right? It should have a certain date whatever that we want to, if we are presenting it on to a bank, right? Similarly, in an insurance industry, somebody wants to endorse something. Another example, which you might be even aware of, right? So each time you get a challan, right, while driving fast, or some other penalty, while what you're doing, so it's the authority, right, which is approving the changes. Now after a couple of licenses, a couple of penalties, your driving license can get revoked, or it can get suspended for 1 month, something like that. So all of those penalties, all those endorsements are basically done by somebody at the back end, right? So that's typically an endorsement, right? And then this endorsement is an action to a response for a request, right? Again, so whenever you jump the red light, there is a notification which goes from the red light to the backend system, and then it goes to the RTO for some penalty, for some action. So that's what. So upon notification of that action, the court of law will actually revoke your driving license or whatever, right? So typically endorsement is governed by some rules. Once the rules are complied to, then the output state is changed, right? A check gets paid or something like that, right? Here we are talking about endorsement between more than one organization, right? 2 organizations, 3 organizations, and so on, right? So as I was giving you that example, right? So let's say Sumit is an organization, I'm an organization, right? Unless I comply to the contract, what's the contract? I should pay the complete amount of the car to Sumit before he makes a vehicle transfer to me, right? So that's basically a contract which endorses a transaction, right? So that endorsement has to happen in like that, okay? So I'm going to skip a few slides, please do not worry about it, it's just text which I have picked upon. Now, the problem here is, when you talk about transactions, right, it's really important that the trust is complied to. Unless, as I said earlier also, internal within an organization, trust is implicit. You don't have to do that, right? But then when you are actually doing a business with business outside the organization, that's when it's really important that the trust is established for fraud prevention, for audit and on, right? So let's say, I asked Sumit, okay, once you send the vehicle to me, I will make the complete payment. So let's say this example. And in case I receive the vehicle and I do not pay the money back to him, right? So what we are doing, we are breaching the trust here, right? So that means the endorsement for this transaction was not correct, and hence the transaction did not happen correctly, right? Okay. Rashid, I guess there are no cloud credentials, right? So in order to learn this, all that you need is an institutional ID, Rashid. In case you are from IIITDM, let's say, then they provide for abc@IIITDM.ac.in. Perhaps that's the email ID that you provide, right? So the moment you try to register with that, you will be able to get access to that content that I was showing you a while back. Okay. Okay, so let me go back here, right? So let's come back to the consensus, right, piece that we talked about. So here we're talking about a peer-to-peer network of nodes, right, which are basically nothing but managing the shared and replicated ledgers, right? So consensus is the overall glue that holds this network together. Typically 3 features in any consensus mechanism. 1, agreement, that which is the correct process, which conforms to the right value, agreement. Second, the validity. Whatever value has been agreed must have been proposed by some other process, the validity of it. Third, the termination of it. Every correct process decides on the value, right? So 3 basic features of a consensus mechanism, okay? In order to arrive at a consensus, what we typically call as atomic broadcast, which is very relevant from a consensus point of view, right? So typically atomic broadcast is 2 asynchronous events that broadcast and deliver multiple times, right? But the important point here is the broadcast ensures that each correct node outputs or delivers the same sequence of message through the delivery event. So if you remember the infograph where there were multiple inputs coming into the ordering service, right? So ordering service role was to basically sequence those incoming requests in a certain order and each time you replicate the same, the order should not change, the sequence should not change, right? So that's what is about the atomic broadcast properties: validity, agreement, integrity, and the total order, right? So yeah, that's what I just explained. The most important is, in distributed systems which are prone to like n by 2 node crashes, the system should really be should not crash down, right? And that's why we have the protocols today called as paxos or vsr, right? View stamped replication protocols, which basically conform to the atomic broadcast things. And for that we have Kafka, we have Raft today, which is available. So Hyperledger Fabric typically achieves consensus by a backend service, all the ordering service we already talked about, right? Which intermediate, it's like an intermediary between the sender and the receiver, right? And what it does, it basically ensures that the messages coming to the receivers are in the same order each time, right? So that's what typically. So I was talking about the Kafka, which provides for a ZAP protocol. We discussed this earlier, right? That what Apache Zookeeper, which is used in Kafka, does. It's not a consensus algorithm, guys. Kafka is typically a centralized service which provides for that sequencing of incoming data packets. And the ZAP protocol inside Zookeeper, which is a member of that, is basically used not just by this, but then by many other systems as well, right? So Kafka is nothing but a distributed streaming platform with a PubSub model. Okay. Okay. Some questions. Yeah, this is absolutely correct. Institutional email ID, Vijaya Lakshmi ma'am, right? I hope that this email ID will get you access once you register on that portal, on ibm.biz/academic. Let me give you the portal here, the URL here, ibm.biz/academic. This is the URL which you can access in order to get the access. Okay. Other than Kafka, right? So the second thing that we talk about is Raft, right? Which is a recent addition again, right? But then it's typically available with the 2.x series. It's a leader follower type algorithm, and it's not Byzantine fault tolerance, right? So we'll see more of the Raft in next few slides. Okay. Yeah. Now, why is so much of a focus, or why is so much of a importance on ordering of this entire system? I'll give you a small example. Let's say I have $50 in my account, right? Now, okay, yeah, let's take this example. So let's say I have $20 in my account, right? And then somebody deposits $30 as well in my account. Now the overall value of my account is $50. Now, if I pay Samir this $50, that means the $50 is debited in my account, and my account balance now will be $0, right? Now, but let's say if the order changes of this overall, right? Right, and what will happen is if there is a debit of $20 first, right, from my account, and then there is another check of $50 which is coming to my account, right? What will happen is, since the second time when the check actually comes to the account, the value available in the account is only $30, and that means the check is going to bounce. So the important point here is the sequence is really important of the activities that you actually bring to the the way the transactions are done, right? So that's what ordering is really important. Yeah, we talk about Apache, and both of Apache, Kafka, and the Raft are crash fault tolerance. So what it means is, crash fault tolerance is as long as the majority of the ordering nodes are good, it does not matter whether a particular node goes down or not, right? So let's say if it's a 3-node ordering service, 2 out of 3 is still good to go. If it's a 5-node ordering service, normally these ordering nodes are kept in odd numbers, 3, 5, 7, like that, right? So what happens is, even if a couple of them goes out of service, so 3 out of 5 is good. So that means the network does not go down. The consensus or the ordering service does not go down. So that's really important, right? And it's important because for a network to operate in a very right conditions, it's really important that it should be fault tolerant. Okay. Okay, let me stop sharing here. Now, can you see my browser, guys?
No, sir, it is not visible right now.
Okay.
Yeah, now it is visible, sir.
Okay. Okay. So what I was trying to explain to you was, uh, from the same environment, right? You when you work on this, you do not have to worry about the other aspects which I just said, right? Creating those nodes, having those single node or multiple node, see, crash fault tolerance service that I was just talking to you about, right? So the moment when you create it, it will ask you when you instantiate that particular ordering service, it will ask you whether you want to. Let me just show it to you just a moment. Okay. So let's say I want to add an ordering service. Okay. See this. I say, do I want to import an existing ordering service? I want to create a new one. So let's say I say I want to create a new one here. Right. So next. Now see, it is asking me number of ordering nodes, whether I want to use a one ordering node or five ordering node. Now, right now it's not, I'm not able to select this. Why? Because I'm using, one single Kubernetes cluster, the free Kubernetes cluster for hosting this entire service. I have not used multiple clusters, to do that. So it's not allowing me to use five ordering nodes because I'm anyways running on one node only, right? So that's the reason. But then see this, when you create the service, it typically asks you whether you want to create a one ordering node or a five ordering node service, right? So unless you want to have if this is a production ready or a production capable platform that you want to have, then it is advisable to use a five ordering node service. But then if it's only a testing or maybe only a staging environment, maybe then you can have a one ordering node service, right? So let's say anything test, right? So see this, right? So the moment I'm actually adding a ordering service, it is asking me which or this ordering service is connected to which certificate authority. Why? Because the ordering service needs to get a identity certificate. Remember that? So I already have two CAs, two certificate authority here. So I can connect to this. It is to either of the two, right? So I can connect to ordering service certificate authority or the other one, right? And then what is the enroll ID here, right? So I can give this enroll ID and I can give some password along with that. And it asks me which MSP is this ordering service going to, be connected to. So I can select that. I right now two of them over here. I can pick one of these. And see towards the end, it asks which of the fabric version, would you want it to adhere to 2.2.4 or 1.4.12, right? So entire thing is basically driven over here, menu driven. It makes the life of pretty simpler for a network operator. I'm not saying the guy who is creating the developer and all, right? For development part, right, you can always use it for developing a smart contracts using Visual Studio Code, VS Code, right? It provides support for that as well. There is basically a complete tutorial it available in case you would like to get your hands dirty on this. It helps you create a VS Code solution, a small one, just to get it started, right? So I'll stop here, guys. Okay, and I would like to take any questions if there are any. Guys, any questions for you?